Today we are going to learn about normal distribution. Normal distribution is a probability distribution method which describes how the data are distributed from the central value. To learn more about the normal distributions, we go through one example. The example is a factory has total 2,000 workers and they have average daily wages of rupees 1,000 with a standard deviation of rupees 200. The wages are normally distributed. How many workers are expected to have wages more than 1,200? Second question is less than 700. Another between rupees 900 and 1150, and between rupees 1300 and rupees 1400. So from this example, we clear our knowledge more precisely from the about the number distributions. So from the questions, we write the information as the given information is how many workers are there in the factory? Total number of workers. Capital N denoted by capital N equals to 2,000, and their average wages denoted by mu equals to rupees 1,000, and standard deviation of wages standard sigma equals to 200. That means the wages of every workers has been deviated by rupees 200 from the central value of rupees 1,000. So we solve the first information. The first question is A. What is the chance of getting? What is the probability? Probability of wages more than rupees 1,200. 1,200 is what? Here. To calculate the probability of wages more than rupees 1,200, we go various steps, 2 or 3 steps around to solve this problem. And the first step is we have to calculate standardized normal variance value. That means Z score equals to x minus mu divided by standard deviation. X is rupees 1,200. Mu means 1,000 divided by standard deviation is 200. 1, the value results 1.00. We put 2 digits after the decimal. Referring to normal probability distribution table. The probability area at Z equals to 1 is 0.0398. Then at first we calculate the Z score, then after we find the probability area at the score of Z from the normal probability distribution table. Then after we draw a figure. The figure is normal curve. At the central line, we put the value of Z as 0 and mu equals to 1,000. The question is concerned is the wages more than 1,200. So we locate the 1,200 on the normal curve at the right side of from the central value. At the right side from the central value, where Z has been calculated as 1 and X is denoted by 1,200. After locating the value of Z as 1 at the right side from the central value, then we have also find out the probability area, which is 0.098, and it has been located from the central value up to Z equals to 1, which is 0.0398. And the last step is that we set the area. The shaded portion is linked with the questions. The question has said that what is the probability of wages more than 1,200. So we set the area more than 1,200. That means the far right part of the normal curve. Here we know that the total probability value is 1, and the normal curve, the central value at normal curve breaks the 1 into 0.5 in 2 equal parts, 0.5, and the right part is also 0.5. Here a probability of wages more than 1,200 equals to what? And it is represented by P. X is more than or equal to 1,200. This means From the normal curve, it is denoted by Px is more than or equal to 100. Then we convert the value of x into the z value. So P 0. Z is more than or equal to 1. It means 0.50 minus P z equals to 1. 1 0.50 minus the area at z equals to 1 is 0.0398 or 0.4602. 46.02% is the probability of getting wages more than 1200. The required number of workers, then the required number of workers getting more than 1200 is total number of workers is 2000, capital N multiplied by P. X is higher than or equal to 1200. 2000 multiplied by 0.4602. The answer is 920. Approximate 920 workers may have the wages more than 1200. The second question is about what is the chance of getting wages less than rupees 700, and the same process we followed at first. We calculate the value of z score. Z equals to x minus mu divided by standard deviation. X is 700 and mu is 1000 divided by standard deviation of 200, and the result is minus 1.50. Then referring to a normal probability distribution table, the probability area at z equals to 1.50 is 0.4332. Then we plot the normal curve to locate the value of z score and find the probability area. The central line is denoted by mu equals to 1000, z equals to 0. Then we locate the value of 700 at left side of the central line because it is less than average value, which is x equals to 700 and z equals to minus 1.5. And the probability area from the central line up to the z equals to minus 1.5 is 0.4332. And once we again focus on the questions, which is what is the probability of wages getting less than rupees 700? The less than 700, the part of the normal curve is shaded far left side of the curve, which is the left part of the normal curve is denoted by x equals 700, and it is what? Here P x is less than or equal to 700, and converting into z value, P z is less than or equal to minus 1.5. The half of the probability area of the normal curve is 0.5. Then we get the result, subtracting the result from the 0.5 minus P z equals to minus 1.5. 0.50 minus 0.4332. The answer is 0.0668, and it is or 6.68%. So the probability of wages getting less than 700 is 6.68%. Therefore, the required number of workers is n multiplied by P x is less than or equal to 700. 2000 multiplied by 0.0668. Approximate 134 workers. The third question is what is the probability of wages between rupees 900 and 1150? Here it is better to solve the given information putting into two different portions of the table to make understand easier. The first is x equals to 900, x1 equals to 900, another x2 equals to 1150. The z score can be obtained by x1 minus mu by standard deviation. That means 900 minus 1000 divided by 200 minus 0.50. Z1 in the same way, Z2 is equals to x2 minus mu divided by standard deviation. 1150 minus 1000 divided by 200, 0.75. Then referring to normal probability distribution table, the probability area at z score of minus 0.5 is 1915. In next part, the probability area. The probability area at z score of 0.75 is
0.2734.
2734. Okay. Then we plot the normal curve to locate the score of z as well as probability area that we have calculated. The central line is denoted by mu equals to 1000, z equals to 0. On the first variable 900 is located at left side of the central value, which is x1 equals to 900 and z1 equals to minus 0.50, and the probability area from the central line is 0.1915. The value of rupees 1150 is located at the right side of the mid value, which is x2 or 1150, and z2 equals to 0.75. The probability area from the central line is 0.2734. And once we look on the question there, which is a probability of wages between 900 and 1150, and the concerning the questions, we set the number curve as the mid part by joining the left part and right part. Here the question can be represented by probability is between 900 and 1150. 900 less than x less than 1150. We can also less than or equal to, because our normal distribution is the continuous probability distribution method, so we can write less than or both less than or equal to. It means p is minus 0.5 less than or equal to z less than or equal to 0.75. P z equals to minus 0.50 plus p z equals to 0.75, and the results we get from 0.1915 plus 0.212734. Combining both probability area, we get 0.4649, or 46.49% of the total employee will have the other wages between 900 and 950. Therefore, required number of workers equals to n multiply p 900 less than equal to x less than equal to 1150. 2000 multiplied by 0.4649. The result is 930. Approximate 930 workers will have the wages between 900 and 1150. And the fourth question is, what is the probability of wages between 1300 and 1400? And to solve the problem, we again form a table to make understanding more easier. The first variable x1 is 1300 and another x2 equals to 1400. We again calculate the score of z. z1 equals to x1 minus mu divided by standard deviation. It means 1300 minus 1000 divided by 200 means 1.5. And z2 can also be obtained from the same formula, x2 minus mu divided by standard deviation. The x2 is 1400 minus mu is 1000 divided by 200. That is 2.00. Referring to normal probability distribution table, the probability area at z score of 1.5 is 0.4332. In another column, the probability area at z square of 2 equals to
0.4772.
Okay. From the given information, we plot the normal curve. The central line is denoted by mu equals to 1000, z equals to 0. The variable of rupees 1300 is located at right side of the normal curve central line. X1 is 1300, Z1 is 1.5, and another variable x2 is 1400, which is higher than 1300, so it has been located far right side of the central value, and Z2 is 2.00. From the above information, the probability area of Z1 1.5 is from the central line is 0.4332. and the probability area at Z2 equals to 2 is 0.4772. Here, the probability of value of x between 1300 less than x less than 1400 converting into z, p 145 is less than z less than 2.00.
2
Pz equals to 2 minus pz equals to 1.5. 0.4772 minus 0.4332. The result is 0.044 or 4.40% is the chance of getting wages between 1300 and 1400. So therefore, required number of student equals to total number of workers is 2000 multiplied by 0.044. That means 800.
88.
That means 88 students. That means 88 workers will have the wages between 1300 and 1400. In this way, we can calculate the normal distribution.